This question looks at applications of trig functions. So in this question, I'm obviously going to work through it and talk you through how to solve it. But along the way, I'm also going to give you some hints and tips that can be really useful, not just for this question, but potentially for other worded and problem-solving questions in the future. So the first thing I do is I use what I call my 3-color highlighter method. So I take my first color and highlight what is the question actually asking. Now this question you will see has several parts to it. So if it's a multi-step question, I only ever highlight the first part to begin with, and then when I'm ready to solve the next part, that's when I'll highlight some more. So this question is asking me to draw a diagram. The next thing I do is I get my second color and I highlight 1 to 2 keywords that will help me answer that question. So for this case, I'm going to highlight sinusoidally, which tells me that it's a sine graph. Then I'm also going to highlight rising when it starts. So that tells me that it's a positive sine graph. The third color is used. What I'm going to do is highlight basically all of my maths. So any variables, any values, anything that I will have to either substitute in or manipulate in some way. So I've got radius of 25 meters. I've got 1 meter above the ground, 1 rotation every 24 seconds, and 26 meters above the ground. Now that I've highlighted all of my key information, I'm ready to answer. So I start by drawing my diagram. So I've got my Ferris wheel and it sits 1 meter above the ground. So I start by putting that in. It tells me that it has a radius of 25 meters. So there's my radius of 25 meters. And then I know that a person is sitting 26 meters above the ground. So that person is sitting there at 26 meters above the ground. One other piece of key information that I would put in here, so obviously I know what my minimum point is here. I'll also put in my maximum point. So I know that at the highest point, I'm going to be 51 meters above the ground. Now, something that this question doesn't ask for, but I think could be really useful here, is what I would also do is draw a really basic sketch of a sine curve. The reason for doing that is so you can get just an idea of your quadrants, you can get an idea of the basic shape, and you can also obviously get an idea of things like period, amplitude, equilibrium. So by looking at it here, I know that 26 is at the middle. I know that 51 is at the side. By the way, when you draw a graph, you should always use a ruler. I've got 1 there. So then all I need to do is draw in my basic shape. Apologize for my dodgy drawing. This is supposed to be the same size, but you understand. And what I'd also do is I'll just put in some key information relating to the period. So I know that one's 24 seconds, which means that this is 12 seconds. So here would be 18 and here would be 6. So now I've just got a really basic sketch that I can use to help me potentially later on. Part B, write a sinusoidal function that describes the person's position. So once again, I go back to my highlighter. So it's asking me to write a sinusoidal function. So in order to do that, I always start with my basic equation first. So f of x equals a sine bx plus d. So the 3 steps that I always say: write the rule, substitute, and simplify or solve. So in this case, we're up to the substitute, but we can't substitute if we don't yet know the values. So let's work these out. So we've got a, b, and d. So d, I know, is 26. There's 3 ways from this information that I can tell that this is 26. First things first, my question actually tells me that they're sitting 26 meters above the ground when it starts. We also know it's a sine graph. So sine graphs, as you know, start at the equilibrium and go from there. The second thing was when I marked it in here on my diagram, I could see that 26 sat at the middle of my values. The third way, if you remember that we can work out an equilibrium, is you simply take the average of the maximum and the minimum. So 51 plus 1 is 52, divided by 2 is 26. So there's three ways that we have now just been able to identify our D value, or our vertical shift. The A value is our amplitude, so how far above or below this equilibrium does it go? In this case, we know the radius is 25 meters, so that means our A value is 25. Finally, B, we know is equal to 2 pi over the period. We were told in our question that one rotation every 24 seconds. So therefore, B equals 2 pi over 24, which means B equals pi on 12. Now that I have my values, I can substitute in and I can write this function. So a lot of people use y and x, or f of x and x. However, it can be really important or useful to write it relating to the actual variables or information that we're using for this question. So for this one, what I'm going to do is I'm going to do h of t, so the height as a function of time, is equal to 25 sine pi t for time over 12 plus 26. So what have I done wrong? I did not define my variables. Bad communication. So I'm quickly going to go back and do that now. So let h equal height in meters, t equals time in seconds. We should always define it. Part C. How high above the ground would a person be 16 seconds after the Ferris wheel starts moving? Once again, I'll start with my green highlighter. What is the question actually asking? The question is asking how high. Now, I've been given a bit of extra information that I'll need to either substitute or manipulate, so I'm going to highlight that in blue, and there is my 16 seconds. Okay. I'm also going to highlight here above the ground. I think that's important, so it reminds me that I need to remember that the Ferris wheel sits 1 meter above the ground. So I'll need to adjust for that in my final answer. So what I'm going to do this time is I take my function that I wrote earlier, h of t equals 25 sine pi t on 12 plus 26. And this time I know that t equals 16 seconds, so I can simply substitute that in and solve. So remember, in a knowledge exam, you have no calculators, so you would have to solve this without a calculator. However, this question is probably closer to a modelling type, so I will let you use a calculator in this case. Remember though, we are dealing in radians, so make sure your calculator is in the right mode. So I always round to 2 decimal places unless told otherwise. So I've got the height after 16 seconds, I can actually change this to 16, equals 4.35 meters. So after 16 seconds, I'm 4.35 meters above the ground. Finally, part D. How many seconds on each rotation is a person more than 35 meters in the air? So for one like this is where I think drawing the graph first is really beneficial. So what I'm going to do is I'm really quickly going to redraw my sine graph. Once again, you would be a lot more accurate than me. You would make sure that you are using a ruler, you're using appropriate scale, things like that. So I'm just drawing this to give you that general idea of what we're going to be looking for. So actually, I'm pretty proud of that one. Yay me. So let's take a look at this. We know that our maximum is at 51 and our minimum is at 1. Our equilibrium is at 26. So we know that this one is at 12:24. This is obviously all in seconds. This point here will be at 18. This point here will be at 6. So at how many seconds? Oh, I forgot to do my highlighting. So how many seconds on each rotation? I think that's important. And then more than 35 meters. So in this case, and mine is going to be a little bit dodgy because I have not used proper ruling, but in this case, this is where it can be really beneficial to get that second line, especially if you're graphing this on your calculator, and put it in at that point that you're looking for. So we're saying that this is 35 meters. So what we're looking for is this intersection, that intersection, and then we can find the difference in between to figure out what that time is. So obviously you can solve that graphically on your class pad by finding intersection points. However, I'm going to quickly talk you through how to do this algebraically. So the first thing we do again is we actually write our function. So equals 25 sine pi t on 12 plus 26. So now this time we've got the height and we want the time. So this time we've got 35 equals 25 sine pi t on 12 plus 26. So let's start working our way backwards. So we subtract 26 from both sides first. So we've got 9 equals 25 sine pi t on 12. Next, I'm going to divide both sides by 25. So I've got 9 over 25 equals sine. Oh, sorry, don't know what happened to my pen there. Sine pi t on 12. So again, if you're using your calculator, next thing I'd do is I would take the inverse of sine. So sine -1, 9 on 25 is equal to pi t on 12. Okay. So what we're trying to do here is we're trying to get t by itself, obviously. So if you can do this all in one step if you wanted to, but I'll do each separate step. So now I'll multiply both sides by 12. 9 over 25 equals pi t. And finally, we divide by pi. So 12 sine -1. Again, if you're having trouble rearranging to get a variable by itself, you need to go back and do some more practice. Equals t. So now we can put that in our calculator and solve. So when I solve this, the first thing I get is I get that t equals, or approximately equals, 1.41 seconds. So here's where having the graph can be useful. So I look at this and I know that my first time does fall somewhere between 0 and 6. So that's really good. However, looking at my graph, I know that I need a second time as well. So there's a couple of ways that we can work out this second time. So what you can do is you can pretty much use, we know that this is symmetrical. So what we can do is we can do 12 minus this 1.41 seconds, and that will give us this second point right here. So let's do that. So 12 minus 1.41 seconds equals 10.59 seconds. So the question says for how long is it above? So how many seconds on each rotation is the person more than? So essentially now we want to find the difference between these 2 points. So amount of time above. It's important to kind of keep track of what you're actually working out. So using little keywords can be very useful. So we've got 10.59 minus 1.41 equals 9.18 seconds. Now, worded question, worded answer, so you can do that. So therefore, ... I'll let you finish that off. Whew, that was a big one, but you did well. So just to really quickly recap, if you're still with me, start off by using the 3-color highlighter method, can be really beneficial. 1 color for what is the question actually asking, 1 color for 2 to 3 keywords that will help us answer the question, and a 3rd color to actually highlight key information that we need to use. My second hint or tip for you is actually sketch a basic idea of that graph so you can relate the function to the graph. 3rd, don't forget to define your variables. And it can also be useful to use variables that relate to your actual question. Again, finally, a graph can be useful. If you are allowed a calculator, graph it in your calculator, get a visualization, find those intersection points so you know what you need to work towards algebraically. If you're still with me, well done. Thank you. This was a long one, but hopefully it's been useful.